Histograms, ogives, and timeplots are the focus of this video, which will wrap up our conversation on numerical displays. Outside of the box plot, the histogram might be the most frequently used graph in AP statistics. We like the histogram because it is used to display large sets of quantitative data, which is oftentimes what we will be working with. We can also make them on our calculators, so that's a nice way to kind of speed up any process. What a histogram does is it breaks the range of values into classes or bins. The classes display the count or the percent of observations that fall into each class. So a histogram can do counts or percentages, a frequency or a relative frequency. So that's kind of a nice feature. While we can have a various number of classes or bins, they're going to kind of look like bars. Each class should have the same width. Here are a couple examples. This one at the top here displays raw numbers, as you can see by the label on the vertical axis. It's approximately symmetric, so I'm kind of using those density curves that we talked about on the front page of this notes packet to look at the shape. Important is that you always label your axes here, and on the horizontal axis will always be our variable of interest. So in this case, we're talking about some type of age. You'll notice that the width between the bars is all the same, the bars being the classes that I referred to on the last slide. The next one down here shows percentages instead of counts. It tells us what the value or the variable of interest is down at the bottom here. It also can include negative values, so there really aren't any limitations to the type of values that we include in a histogram. You can see that this shape has the tail on the left side, so this is a distribution that's skewed to the left. A histogram might look like a bar graph, but there are some important differences highlighted in these lists. First and foremost, a histogram is always used for a quantitative or a numeric variable, while a bar graph is for a qualitative or categorical variable. The histogram has a horizontal axis that is always a number line, so again, we're talking about something quantitative, whereas a bar graph has categories. So it might be something like colors or yes or no, something where a response is not numeric. Another difference is that a histogram won't have spaces between the bars unless there is actually a gap in the data set. So we kind of like how we had gaps on the stem plots. We might have a gap in the histogram, otherwise the bars will be touching each other. And in a bar graph, spaces between the bars have really no impact on the data itself, so it doesn't matter if you space them out or you have them touching. You're going to let your calculator do a lot of the work to make histograms in AP statistics. So the first example that we're going to go through, I want you to practice it on the calculator. The calculator will choose the class widths for you. It doesn't always choose nice whole numbers, but you're really just doing a sketch of the graph anyway so that we can get an idea of the shape. So I don't want you to worry too much about the class widths that your calculator picks for you. I have the prompts listed here. They're also in your book. You're going to enter your data into a list as we've done in class before. Then you're going to turn on a stat plot. So your stat plots are found when you go to y equals, but you hit the second button first. So it's the function over y equals. There will be a spot for you to turn plots on if they aren't already on. Once you go into the plots, the third one over will look like a histogram or a bar graph. That's the one that you want to have highlighted. And then there will be a couple prompts below that after you've highlighted the histogram. The X list, that's when you want to tell your calculator what list you've stored your data in. It's probably L1 listed there already, and that's probably where you put your data. Eventually we'll start using more lists and you'll get comfortable toggling back and forth with those. Your frequency will stay either blank or at 1 for now. Once you have the data in there and you've followed all of these instructions, what you want to do after that is press zoom and then the number 9 or function 9, which is zoom stat. And a nice histogram should show up for you. You're going to want to practice this, and if you don't see a histogram showing up on your screen, chat with one of your classmates and see if they can help you. Otherwise, the next time I see you, we can go over it for your particular calculator. Here is a set of data. This data is a list of IQ scores from 60 randomly chosen 5th graders. I'd like you to follow the prompts on that last slide, so you might need to rewind the video a little bit and try to use your calculator to construct a histogram. You also have this data set listed in your notes for ease of reading. Then what I want you to do is make sure it looks something like the next slide. Because your calculator chooses the class widths, it might not have these values exactly. And like I said, that's okay. We just want to make sure that your shape is roughly the same as the one that's showing up here. And then when you sketch your picture, you are labeling the x-axis, you're labeling the vertical axis, not only with numbers, but with what they're showing. So IQ scores on the bottom and the count of students on that y-axis. You should also make sure you always give your graphs a title, which I've cut off of this picture here, but we would want to make sure that even though IQ scores is listed on the horizontal axis, we identify our population as well. So this is IQ scores of 60 5th graders. Moving on to our next type of graph, the ogive. This is also known as a relative cumulative frequency graph. So we know that relative frequency means a percentage, so it's like a cumulative percentage graph. The two pictures listed here are the same data. They're talking about, looks like some type of score in a class. And this first one lists the frequency, so how many people fell in each category for each score. The next one lists the cumulative frequency. And so this is kind of saying we had this many people get 20, and then we had this many people get 40 or less on their on whatever their mark was representing. So that's kind of where ogives are going. They're telling us how many at that point or how many fell before. So you will always see an ogive increase or flatten out if we didn't have any more data values to contribute to a certain spot. They'll never dip back down as this first one does. General vocab, some of which we've already gone over. Frequency just means count. Relative frequency means percent. Cumulative frequency is a running total of the class and all previous classes, kind of similar to what we saw on a piece of computer-generated STEM plot in terms of finding where the median falls. And then a relative cumulative frequency would be like a running total of percentages. We make an ogive because it gives us information about the relative standing of an individual, so how one data point falls in comparison to the rest. It also calculates percentiles for us, which can be helpful, again, to kind of show where an individual falls compared to the others. And they're fun to make, and it's fun to say. Ogive. So as I go through the steps here, it's probably going to sound pretty confusing on how to make them. And I don't even have a spot in your notes for you to write down the steps because I'm never going to ask you to make an ogive. And I think the chances are close to 0% that you will have to make an ogive on the AP Stats exam. It's more important that you're able to read and interpret them. The only reason I'm going to go through how they're constructed is because hopefully that will help you understand how to read and interpret them. So just kind of bear with me through these next few slides and know that after I go through the language, I'm going to look at an ogive and kind of talk through those directions again with the picture in front of you. So the first thing you're going to do is pick class intervals just as you would if you were constructing a histogram. If you're looking at the example in your notes, we're going to talk about president ages at inauguration. You can see that the class intervals that we've chosen are 40 to 44 years of age, 44 to 49, and so forth and so on. You'll create a frequency table that includes all of those vocab words that we just went over. And you'll see that I already have those columns outlined for you in your notes. So this is what the table looks like. You're going to complete the cumulative frequency and relative cumulative frequency columns just with the aid of your calculator. The first few values aren't that exciting. The cumulative frequency, well, if the frequency is 2, then the cumulative frequency for this first row would be 2 as well, and the relative cumulative frequency is still 4.7 as it was before. What changes in the next row, however, is we want to look not just at this 6, but all of the values previous to that. So we have 6 values, or 6 people who were inaugurated between the ages of 45 and 49, and we had 2 previously. So this cumulative frequency will be 8, and we'll do the same thing with the percentages. This would be 18.7. So you want to continue to do a running total. You should end up with 100%, a little bit of round off error, and 43 at the end. So go ahead, pause the video, and complete that. Here I'd like you to just check your work. You might have some different rounding than what's listed here from your textbook. Do not worry about it whatsoever. All of these values are going to be good enough for us to get through this example. Once you've completed your table, you're going to start to construct the graph itself. You're going to draw axes, just really the first quadrant, label and scale them. Also, you'll include a title on your graph. Your horizontal axis is going to be the value, or the variable rather, that you are measuring. So down here we're going to have our ages. And the vertical axis is going to go from 0 to 100 because we're talking about those cumulative percentages. So you'll want to label that as relative cumulative frequency or cumulative percentage. As we're putting numbers on the axes, we're actually going to use the minimum value from each of the classes. So you're going to have a tick mark to represent 40, another for 45, 50, 55, and so forth and so on. It's usually pretty reasonable to label the y-axis by tens since it's always going to go from 0 to 100. Step 3 is where you actually start to put some data points on your graph. I know that my graph up here looks really bad. I'm going to show you a good one in a minute, but just going to do this rough sketch to give you an idea of what I'm talking about as we go through these instructions. So you're going to begin your ogive with a point at 0% at the lower class limit of your first class. So again, our first class went from 40 to 44, so we're going to put down here right at 40, 0%, a point there, because at 40 years of age, we had 0% of our presidents inaugurated before that age. Next, we're going to plot a point corresponding to the relative cumulative frequency in each class interval at the left endpoint of the next class. So our first cumulative frequency, relative cumulative frequency was 4.7%, so roughly 5%. So I'm going to go to the 45 and put a dot right around 5%. The next relative cumulative frequency was somewhere around 18 or 19%. So I'm going to plot that at the minimum value of the next class. So I'm going to try to go up here just below 20. If I can get my marker to write. There it is. Okay, so I would continue on in that manner, kind of plotting each relative cumulative frequency at the starting point of the next bin. Then, let's see, so our last point should always be at 100%, and we're going to connect the point with straight lines between them, not curves. So it's going to look like this and continue to crawl. So here is a much better picture, this one coming from your textbook on page 61, of what the completed ogive would look like for the ages of U.S. presidents at inauguration. I've put those relative cumulative frequencies and the classes over here just for reference. As I was constructing before, you can see that we started at 40, with a point at 0, because at 40 years of age, 0% of presidents were inaugurated before that age group. At 45, we had 4.7% inaugurated before that age, and so forth and so on, up to 100% at what would be the start of the next class, would be 70 up to 75. As promised, reading these graphs is going to be more important than making them. So I'm going to go through how to locate an individual or locate a particular percentile, which is most likely what you'll do with these graphs. So if we wanted to find where one particular data point fell, we would find that data value on either axis, and we would walk over or up to where that graph, the line falls. And then we would walk down or over to the other axis to find its corresponding point. I'll put a picture up in a second to go through that. If ever we're asked to find the center of the ogive, it should be no surprise that the center is going to correspond to the median. Really hard to find the mean of an ogive, so we're always going to use the median when we have these types of graphs, and that's going to correspond to the 50th percentile. Because the percentiles or percentages are on the y-axis, we'll go to 50% on the y-axis, walk over to the graph, and then walk down to the corresponding data point. So here's how that's going to work. If you look at page 62 of your textbook, that's where I pulled this picture from. And on page 62, it asks us to find the percentile that corresponds to President Bill Clinton. Bill Clinton was 46 years of age when he was inaugurated. So what we've done is gone to where it looks like 46 might fall. And so these are going to be approximations. We're walking up to where that value would meet the graph, and then over to see the corresponding percentile. So it looks like Bill Clinton falls in roughly the 10th percentile. What that means is that in respect to their ages, there were approximately 10% of our presidents that were inaugurated at age 46 or younger. The graph below is the example of how to find the center of the distribution. And we could easily find any percentile we wanted, but this one does the 50th percentile. So this one started at 50 on the y-axis, walked over to where the graph was, and down to see that the 50th percentile is roughly 55, which would mean approximately 50% of presidents were 55 or younger when they were inaugurated, and approximately 55% were older when they were inaugurated. This particular value looks like it falls right on one of the dots. That won't always be the case, so I just wanted to point that out. Also, any other percentile will work the same way. So if you were asked to find the 85th percentile, you would go wherever 85 is, walk over, walk down. It looks like that might be about 63, 64 years of age. Because these are, it's not exact to read these graphs, I will accept kind of a range of values when we give specific answers. All ogives increase or flatten out at a certain point, so they don't clearly tell us the shape of a distribution. It's kind of hard to tell if the distribution is symmetric or skewed. Similarly, it's hard to tell what the spread of the data is outside of the range. So describing the distribution isn't necessarily something I'll ask you to do for an ogive itself, since the only thing you can easily find is the center. But if you do have the data available to you, you would enter the data and maybe make a histogram in order to identify the shape. You would use your 1-bar stats if it were appropriate to identify, say, the standard deviation. The last type of display that we will talk about in this video is called a time plot, and it's really different from the others. It's kind of similar to the ogive. It doesn't really tell us much about the shape, the center. It does tell us about the spread of a distribution, but it's not best to be used when we're trying to find the shape and the center of a distribution. A time plot is best used when we're trying to see if there is some type of systematic change over time, where our other graphs really kind of ignore that time order. So that's kind of a downside to those. For example, the ogive that we just looked at for the president's ages at inauguration, if we were to look at where their ages fell in the order in which they were inaugurated, I haven't actually made the graph, but we might see that presidents are getting younger at their age of inauguration, or we might see a period of time in which we were tending to elect older presidents than another period of time. That's what a time plot shows that any of the other graphs we've talked about do not. So a time plot of a variable plots each observation against the time at which it was measured. So it doesn't take into account frequency, relative frequency, or any cumulative frequency. Constructing a time plot is easy. Reading a time plot is pretty easy. You're always going to put time on the x-axis. Unlike most of the other graphs where we have our variable of interest on the x, in this case, the variable that we are measuring is going to go on the y-axis. So that's one difference compared to a lot of the other plots. Kind of like the ogive, we're going to connect each point with a straight line. Here are 4 different examples of a time plot, each one showing a different unit of time on the x-axis. We've got years, we've got hours. I'm not sure what exactly this last one is. It doesn't give me a lot of information. And then we have some variable of interest, a quantitative variable, a numeric variable on the y-axis. Like the ogive, the time plot is the other exception to the shape, center, and spread rule. We're just going to describe the time plot as we kind of walk from left to right as time passes. So for example, if I were to describe this time plot in the upper left-hand corner, looks like my variable of interest is completed fertility. So maybe it's on people who are completing fertility treatments to try to get pregnant in these years. I would say something like completed fertility decreased from 1920 to 1940, then started to slightly increase until about 1950, and then increase a little bit faster until 1960. And that would be pretty sufficient. The only way I might improve that is to include some of these actual values. For this next one, it looks like we're increasing and then we kind of flatten out. So that might be something you say about a time plot. You could talk about this last one in the lower right hand corner of as being really erratic. It goes, up and down, kind of toggles between 40 and 60 until we get to a time of roughly, I don't know, that looks like maybe 18. We have a sharp drop, and then, it's erratic again. It has a peak at about time of 28, and that goes up to roughly 85. So, there are a lot of different words that you might use when you're describing these. We might say that this in the lower left-hand corner generally increases with a few kind of dips around 12 and around 30 years. To wrap things up here, a few other things to keep in mind. When we're talking about shape, any peak is not representative of a mode. It's not the value that most often occurs, it's just the highest value of that variable. We usually discuss trend over time, as I was trying to do for you on the last slide, so we don't use those common words to discuss shape like symmetric or skewed. Because our variable of interest is actually on the y-axis, you want to be careful. If you are asked the median, you should be able to find it, but you're looking at the y, not the x. And other things to mention here, you could mention the range, but again, look at that y-axis. And we're kind of looking at, how much does that variable change over time, so that's what the range would represent. That concludes this video and should bring you to a point in your notes where the next heading is box plots and outliers, and we'll work on those next class.